Thermal performance testing on the window system. We tried a couple of different methods on how to measure the temperatures and the temperature rise in this wall system. We came to find out that by keeping a distance of 6 feet away from the wall, we can actually get a good average. After we measured each block up close, we took the average across every block. We found that 6 feet away gives us exactly the average within. This is not the most accurate tool there is. I believe it has a plus or minus of about plus or minus 2, so it could be off as much as 4 degrees. I think it's fairly decent for what I'm trying to do. It tends to be probably off in the same direction, I'm hoping. So we're measuring inside temperature of the wall, which is halfway across the room. We have no heating system in here. We're still not insulated in the cathedral. We're not sealed around the windows. Today we had about, I would say about 20% sunshine over the course of the day. We probably captured around an hour and a half to 2 hours of good solid sunlight. These window systems were 69 degrees when we came in here this morning. The temperature outside was 47 degrees and the room temperature was down to 60. So it was a little bit not quite comfortable, and I think by sealing up some of the scuttle holes, we put some plywood over there just to stop the air from coming in through the attic space. Should help. So over the course of the day we had a temperature rise across each one of these windows individually. And we measured it at different times of the day. We marked down the amount of sunlight that was shining at that time of day. We measured the indoor temperature and the outdoor temperature at each course of the day. So we started at 47 around 7:30 this morning. We ended up we're at 50 right now. It's 5 o'clock in the afternoon. We reached a daytime high of about 57 degrees. The temperature inside the house started at 60. Right now it is 65 degrees in here. It's climbed up to as high as 66 degrees a couple of hours ago. So it's dropped a degree in the last couple of hours. But these window systems all came up across the board to the 81 to 82 degree range on average. So we had a temperature climb of about 12, 13 degrees on average across the window system. If we take the total mass of the window, which is 3,000 pounds of water contained within this window system, and we multiply that by 12, or 13, so if we multiply that by 12, we'll come up 12 times 3,000 is 36,000 BTUs of thermal energy that this window's been able to capture and store within that water right now. You can actually feel the heat radiating off of this into the space. And if I take a temperature reading on the outside of the glazing beyond this, you have almost no heat loss outward through that window system. So because of the selective glazings they used, 90% of that heat is transmitted into the space and not out into the outside air. It has to do with reflective glazings and selective surfaces on the exterior glazing of this unit. So we're going to continue to monitor this and see how it goes. Hopefully we get a couple of good sunny days where we get 6 or 8 hours of good sunlight and really charge the system up. We've had it up as high as 104 degrees was the highest temperature reading so far, which was on Sunday. We're going to get a cold snap the next few days with high temperatures in the low 50s, probably down around freezing at night. If we get a couple good sunny days, we'll let you know how this thing's performing. We'll keep measuring this and testing this and let you know how it performs. So far so good. Don't know what you think about the appearance of it, but I'm amazed at how nice it looks. And I'm very, very happy with the performance of this wall at this point in time. It can save a lot of people a lot of money, and if things are designed right, it really looks wonderful on the outside of the building.